No, I did. This is your mic. I'll give it to you. Welcome to the data engineering meetup. I'm glad you made it out here. Traffic was interesting for me, at least. So, so this is the latest. No, yes, this is the latest I've gotten here, and the longest it's taken me to get here. And I've been doing meetups at Recursion for 3 years, so it's interesting. We'll start with announcements. Is anybody hiring? Sweet. Jake will be hiring. Gotcha. Okay, so as soon as it gets approved, Jake will put it in Forge Slack, and you can all apply. You already have a job. Quit complaining. No, it's like okay. I'm just giving him a hard time because, anyway, sorry. He was looking for his first job and he got an offer anyway, so I'm just giving a hard time. I want more money. Exactly. Actually, no, it's going to be in 3 weeks, so I'm already ready. You're ready to move up, so get that first promotion. If it's your first time here, we do have a Slack channel. It's a Forge Slack. You can join. Just go to forgeuta.tech. That's where the jobs board is that I mentioned that Jake will put the thing on. There's a data engineering channel that's been weirdly silent recently. Everybody keeps posting in the All About AI channel, and nobody wants to talk about Duck Lake. That was the last big thing, I think, was Duck Lake. Duck Lake, it's a open table format, but with Postgres as the metadata layer instead of Iceberg. Duck Lake.
I think AI has taken over this lecture.
Oh gosh. We should make one, shouldn't we? That'd be hilarious. There was a while back, there was a crypto believers and a crypto non-believers channel. And the people from the non-believers channel just trolled the people in the believers channel. But the people in the believers channel didn't know what to do in the non-believers channel. So I'm totally fine with right? Because everything is all about AI, and then there can be another one that's like no AI allowed or whatever you want to do. Yeah, anti-AI. Totally fine with that. Yeah.
I don't know where to go. I'm not anti-AI. I am solidly anti-vibe coding. Yeah.
Well, that's half of what the AI channel is just talk about vibe coding. So.
I'm thinking about uninstalling quad code like every other day. I need to get stronger. And that would be the first one to post that.
Okay. Great. You can make the channel right now.
Oh, yeah.
Okay. Well, I'll join after the meetup. I'll join. Okay. Announcements next month's data engineering meetup will be in Lehigh. Tentatively, we're going to be talking about star schema because that was one of the suggested topics I gave. And then we'll be back here in November, and that talk will tentatively be about semantic layers. Just have to confirm. Again, it's tentative. I posted looking for speakers, and so I got a couple of responses, so it's tentative. I'm still looking for speakers. We will most likely have a meetup in December because it'll be the week before Christmas. I will ask in November if we want to have a meetup in December. So if somebody's willing to speak, we'll potentially have a meetup, and then obviously I'm looking for speakers for next year because I'm always looking for speakers. Mary Welsh.
Somebody mentioned that they want.
Well, they should talk to me. I really want speaker. I want everybody to speak. Miguel just like literally reached out to me during the last meetup and said, "Hey, I'll speak." So like and I was like, great, you're already assigned. Too bad. So it works out really well. Next, speaking of vibe coding, next week there is an MLOps meetup titled "Do You Even Vibe Code?" The speaker will be doing a live vibe coding session. That's the whole talk. So it'll be interesting. I expect that to be really well attended because AI. And then Ford Utah also has a Go conference. If anybody wants to attend, that is October 24th. I will be there because I run it and I'm speaking. So that was not for applaud. I got coerced into speaking. Cool. We'll turn the time over to Miguel, who volunteered to speak to us. Feel free to ask him any questions. And yeah, here goes. Give him a round of applause.
Oh, I can put it here. Sorry, too much technology for me right now. Perfect. Can you guys hear me? Perfect. Thank you, guys. So, yeah, my name is Miguel. For those who don't know me, I'm a software engineer / platform engineer at Ensign College, just a couple of blocks away from here. And yeah, I'm actually where I'm studying right now. It's been fun. Right now, it's been a challenge. You need to wear many hats at the same time, including data engineering. That's why I talked today. Not all data needs to be real time. I want to start with a little story. Our team, or my team, is called the Tech Lab. We offer support to the Ensign College, to the whole university, plus BYU Pathway. For those who don't know, BYU Pathway is an online college or / university that offers certificates and degrees to people around the world. So we're in charge of managing infrastructure, those hard servers, to all of them. We have 50 plus. Some of them are in Africa, others in Asia. So we have to be in charge of them. So because of that, we tend to work sometimes very late at night. So feel the struggle. So this is an actual picture, actual footage of some of the servers that we have in the university. It's been fun working on those. So you might be wondering, why does a platform engineer / something is going to talk about real data pipelines? Well, with servers like this in a sandbox environment, we allow students to create VMs for them, and they tend to overcreate them. What do I mean? Instead of following the instructions of using 16 gigabytes of RAM or less, they have created 240 gigabytes of RAM VMs and so much more. So that makes some of our servers to crash. In the past, we have at least 5 monthly crashes of servers, because we started from a single class of around 20 people to multiple sections up to like 130 students each one. Sorry? That's where we're going to. What we're using right now, it's called Proxmox, and the enterprise solution has the option, but because we don't have the budget for that, because it's a college. BYU probably, but we don't. So you have to work with what you have, right? So that's what we've been doing. So this is actually some of the footage. This is actually footage of students and their work. So we were constantly getting ticket requests that their VMs were not working, that they were having problems, that the servers were crashing. So what we did, we set up monitoring of the VMs. First, we decided to start doing it every day, and start deleting those VMs that were not compliant. The crashes reduced them, but we were still getting some crashes. We reduced it to every 6 hours, to every 12 hours. And then we decided around the hour that, let's do a real-time pipeline. Let's do it on real time. Whenever they created it, let's delete it. It was a fun thing to do. It was not life or death, but it was real consequences. People with the limited time that they have were trusting us to have the enough resources for them to learn. We have limited resources, so we needed solutions built on top of what we have. And we couldn't afford downtime, especially for finals/projects for them. So it was an interesting thing. So this is some of the tools that we decided to do. We wanted to try to solve the problem with better visibility. We thought faster data equals better decisions. And that's our first red flag that it should be. We decided to use Kafka streaming, Proxmox API, and some Java-based code that we decided to do. So the process was simple. We were going to send all the information. This is the thing that we had initially. Feel free to roast me if you want. This is somewhat outdated. We have a better version now. But first we thought that we were gonna get all the inputs from all the servers into Kafka, into different topics. We're gonna then use our policy enforcer, triggering every time something a new VM came up that was non-compliant, shut it down and delete it. And all the other metrics were going to be synced into a timescale database. Why? We wanted to. It was fun. And then, try to figure out how to continue putting that information there, because we wanted to do something more. We want to be more proactive and actually prevent service degradation, right? With a kind of machine learning analysis, which we haven't gotten there yet, but we're trying. Yes.
So are they doing this?
What do you mean, like the whole mess, or like the?
Creating.
They are actually doing it on purpose, not because they are bad or because they are trying to hoard resources, but rather that they don't know. They're just beginners in terms of technology, so they don't know sometimes what they don't do until we tell them what it is. So while it is intentional is not because they want to hurt. They don't know.
What do they have to do to get some storage in this? Like, do they have like a front end UI that they interact with? Is that how it works?
Yeah, it's how it works. They have a front end UI, but it's not like the AWS one. We use the Proxmox default one. We try to create our own UI, but you know how things are when you try to start a project. There's bureaucracy, at least in university parts, where it needs to be approved and everything. So this was most in our realm, so that's why we didn't need to like a green flag or something.
I'm just wondering if you explore the Elk stack at all, or maybe a light version.
Yeah, we actually have one. We have, instead of Elk stack, this is before everything, but now we have FluentBit and OpenSearch with OpenTelemetry. But yeah.
Not enough AI.
Exactly, there's not enough AI. Thank you. We should definitely add more AI. It needs more AI. I'm actually going to talk a little bit about more AI later. Sorry?
The cowbell for AI now.
Or sticker.
That's AI.
Definitely. So this was our use case. We created this data flow. We thought it was amazing. And we thought, how hard could it be? Well, we didn't expect the volume explosion. We thought it was going to be more, but we didn't thought about the scale. There were cascading failures, racing conditions, and system exhaustion, and team fatigue. What this happened? Basically, even though we planned that there was going to be more data, we didn't get rid of garbage data, let's say. While it's data and it's important and it helps us have certain metrics, you don't need them every second or every sub-second, right? You don't need the storage, how full your storage is every second, because it's going to change in a couple of minutes. We noticed we were getting garbage data. and it was slowing us down. If anything failed in upstream, it will affect downstream. So we didn't plan for that, and there were no fail switchovers. So there were no way of us to to solve the cascading the problem without affecting the downstream. Data was coming in different times, and we were having too many I/O errors. The disk was not keeping up because we were using outdated or old servers. And of course, team fatigue. We were being debugging at 4 a.m. our pipelines because they were broken down. So imagine you need to monitor the servers and monitor your data pipeline at the same time. So it's like a catch and mouse, one on one on one. We tried to reduce the noise, and it helped. We tried to do some batching, and it helped. But again, we were trying to cover the sun with a thumb, right? We were trying to solve a problem, but maybe not in the correct way. So this is what we did. We tried to find the sweet spot. We went from real time to micro batching instead of pure streaming. We separated critical versus non-critical metrics, meaning we don't want to need the storage, how full it is every second. We can know about it every hour or so. What we needed was mostly RAM and CPU usage because that's what the people were hoarding the most. We redefined our schemas, getting rid of most of our data. And we just simply embraced the chaos. We accepted that maybe we cannot do everything, right? We cannot be super proactive or super preventive. There will always be failures, and that's okay. You just need to accept it. And we went from trying to do it sub-seconds or every second to 30 seconds. And that has been working for us for now. While doing this, we noticed or we learned something. We thought that this pipelines were going to be either a full host or batching process. Normally, when we say real timelines or real time, we always think of the sub-second or milliseconds or every second processing time. Or when you think of batching, you think, oh, maybe once a day, once a month, or once a year. That's the thing we have, or the concept that we were thinking of before. But then with this experiment and with this experience, we noticed that it was more like a spectrum, let's call it. I know many of you have already figured this out as seniors, but for us, it was an amazing way of learning. We divided now we're dividing our data pipelines into this, let's call it framework. We have it as a hot, warm, medium, cold, of course. For sub-seconds things, we might not work on that, but it is important still. For example, trading systems, industrial safety are the ones that necessarily need sub-second one. For example, Goldman Sachs beating any other capitalist firm by 2 milliseconds could mean profit of $50 million a year or less. So it's essential for them. But for our case of server metrics, it's not. We decided to keep on the warm area around 10 seconds to 30 seconds. That's where our pipelines are mostly, the site reliability pipelines, and also the intrusion detection systems. This is another example of how we are actually using. We are scanning the network to find if there's been any, I don't know how to say it, something suspicious, any packets going to somewhere they should not be going. And we try to be in that area between 10 seconds to every 30 seconds analyzing. We have some medium task. I defaulted the default because most of your data pipelines will be here between every minute and every hour, or maybe colder, analytics, planning, and historic analysis. For example, let's say dashboards of how many things have sold in the last couple of years or in the last month. You don't need it right now or seeing it every now and then, That's why I had the other one. I don't know if you saw it, but yeah. Of course, there's always trade-offs. Something we learned the hard way is that when you are trying to get more into the content, you start getting some trade-offs. while speed is great, you start getting less accuracy, or you're starting to find more edge cases that beforehand in your other places you were not able to see, right? For example, our data, um, sorry, my English is not really good right now. Thank you. I'm gonna ask some words in Spanish, so if someone can help me, that'd be great. So, so the struggle is real. I have to say that it was a great thing to go and try to do in the hot one because we learned a lot. We found that some of our original plans were wrong, and that way it helped us. What I'm saying is that you don't need to do it in hot. I mean, for all you want, you can do it. We wanted to do it because we not only because we tried to fix it, but we also wanted to add it to our resume. Say, well, yeah, we work in Kafka. So if you want to do that route, I respect it. Just know what you're getting into. Now going to AI, because we always have to talk about AI in one of these meetups. We can see a case scenario here too. For example, in live translating applications where one person talking Spanish is talking to someone in English, you might want accuracy, right? You want the translation to be as fluent as possible, right? But the problem is that if you want accuracy, you need to sacrifice speed. Of course, models are getting better. Models are getting quicker. We're getting better hardware. But there's always be that trade-off, that accuracy versus speed, right? Instead of going to classical large language models like ChatGPT or Claude or Gemini, some applications are using now smaller language models that, while the exact word is lost, the meaning is still kept. And they don't have to sacrifice speed for that. So it's always that, it's always a trade-off, it depends. Right? Any questions so far? I prefer to use Claude. I think it's better in general. What do you guys use?
No, I'm connected to Anthropic. Yeah.
Exactly. So we can have full ChatGPT 4 level quality without proper context. You can have everything instantly, right? Real time means compromises, and you just know what you're giving up. And that goes to the next thing about overpromising. Most of data engineering is trying to figure out what our stakeholders want, right? I remember Mariah was telling a story that they wanted a real-time pipeline for a dashboard of sales of the month. Talking with the stakeholder, what they really needed or what they were referring to was a daily report on what's the status of the selling, shopping, etc. So us as engineers have this preconcept of what real time is versus what other people think it is. For them, one day it's real time. It's real enough. So I added this list, because we sometimes have this part, right? When we overpromise and we try to fix everything in there. The reality of trying to build real-time pipelines is that one service can flood your entire pipeline. You need to expect peak load all the time, and your beautiful test environments are lying to you. You'll see edge cases everywhere. And talking back to AI, people want ChatGPT quality responses in milliseconds when it's not possible, right? Exactly. People want that, and we cannot deliver it. Yeah.
Even when you do, it still takes 2 minutes to do it.
Exactly. People want that thing, and they don't want to sacrifice quality. So
Just wondering how you arrived at those seconds and not 1 second?
Yeah, actually, thank you. The reason why we went into 30 seconds and not 1 minute is because we still need to check for every time the people are creating VMs. Students are creating VMs every single day. We have tried actually 1 minute and it went well, but we decided to go it a little bit before because we'll still have some crashes. So
How fast do you react once you like see it? How fast do you react or how often?
perfect. Actually, we don't have to check now. We used to check, but now we don't have to. We have an self-healing pipeline. Whenever we find a VM that is not, well, it's not compliant, it's out of policy, it automatically triggers a Python script that sends an API call to the Proxmox servers to delete it and stop it. Well, stop it and then delete it. Yeah. How many VMs? I won't say enterprise scale, but we have to deal between 5,000 VMs, so a little bit more than that. Yeah, I know. I won't say that's why it's enterprise, but because every student have to create at least one VM. Some of them have to create more because they're trying to, they are learning how to manage data centers or an IT office. Each one of them have to have like experience managing them. So
What's the experience like
yeah, uh, we actually have to do it beforehand. We have to send them an email letting them know at least every week saying like, hey, remember if your VMs are not following the instructions are going to get deleted. So please follow the instructions. We also let the instructors know and they know and they're in charge of that because they know better their students. So we let them know beforehand. Well, it's actually random. Like I said, there's not troublemakers. It's mostly that they don't understand what implies to have 128 gigabytes of RAM. So, but we do have one class that is the one that has the most problems. It's called IT 125. It's like the beginning of IT. You just create a Windows 11 VM and click around and try to find out what it is and everything. And that's the one that we have the most people in it.
Give yourself God mode where you can bypass on a whitelist and like people up with favors, scratch their back.
That's a great idea. We do have like a whitelist. I know.
GPU requirements, just to know.
Just to know, we don't have GPUs. We want to, but we don't have. But we do have like a hybrid cloud environment. So we also pulling data from there because also students are using AWS to build stuff. So been fun. So remember, you need to plan your fallback before building your primary data pipeline. That's what we've learned. If something breaks down in your first one, you have a failover for that one. If you really need to do batching, you don't need real time actually. Sometimes we as engineers want to do the new shiny thing, the new stuff, the flashy thing, things we can put in our resume, which is fine. Again, Kafka, for example. But having a good reason why you're doing it rather than because it looks flashy, I think it's better engineering judgment. That's something we learn. So you'll see Kafka in my resume, you know the story now. Sorry? I will put this talk in my resume. Perfect. Again, real time isn't bad. I know we heard that real time is just something flashy. It's just probably not your usual first choice. Try to find something that works in batching. It will help you time. It will help you save time, resources, and you don't have to wake up at 2 a.m. because it broke down. When you need it for business reason, build it right away. When you want it for learning, own that motivation and just do it. And either way, you know what you're signing off for. So try to see what pipelines you have built this week and try to find something that might be can be optimized. Yes.
You still use solution?
We still use it, but for the triggering jobs and also for the analysis. While we can do it using Prometheus and other solutions and other ways, we want to still use Kafka because for us, we already have that infrastructure that we built before. So trying to remodify everything will be just more time, more engineering, and more headaches. And we still need to find other ways to optimize other classes. So it's basically it. You turn down a fire and another starts, and you just go like that. Perfect. Any other questions that you guys might have? No? Thank you. Well, thank you for listening to me. This is, if anyone wants to roast me on private of my bad engineering choices, you're more than welcome. So thank you guys for your time.